Okay, so here is what we have currently. Um, so this looks pretty cool, right? But now what I want to do is I want to be able to change the size of the light source, the size of the circle with my mouse wheel. So I did it this weekend because I wasn't here at my apartment, so I was at my parents', so I did it on my MacBook, but I didn't push it on the repository. So I'm just going to do it again on here, um, and then I'm gonna try to fix the hair and the light source circle, but I feel like it's not necessary, right? Because I'm always going to display light rays. So I feel like I don't have to fix that. It's not really like a big problem. You can barely see it on videos, so I think it's fine. I'm not gonna bother doing that. Then, so this I can remove. Collisions with other shapes. So yeah, am I going to create an abstract obstacle, a class? I don't know. Um, and then I'll see if I do this part. So right now, change light source size with mouse wheel. So let's think about this because I can barely remember what I did this weekend. I want to be able to like change the mouse wheel using um, I want to be able to change the size of the light source as the radius of the light source. So if I look at light source here, I have a radius attribute, and I want to be able to change it using the mouse wheel. So here in the main file, it's going to be an event. I'm just going to test an event. So if event type is equal to SDL mouse wheel, so there's an event called SDL mouse wheel. That's pretty cool. And here basically I'm just gonna wanna do something like let's see. So light source set radius, and the set radius is just going to be so the radius, the current radius. So so get radius plus event dot like the movement of the mouse wheel. So mouse wheel y, I suppose. Um, I guess it's going to look like that. I think like from memory I can basically just do that. I think it's only wheel. So let's look at it here in the wiki. Complete API index, and if I look at SDL wheel mouse wheel event, right? And then there's XY, so type is going to be mouse wheel, right? And then here I'm gonna have an amount scrolled vertically. So um, this is a mouse wheel event. Okay. And so I think I have to do event.wheel.y instead of just event.y. From memory, I think that's how I'm supposed to do it. So I'm gonna try it this way, and then if it doesn't work, I'll just figure it out another way. So here I have to do set radius and get radius, so a setter and a getter on the light source. So pretty easy this. So void get radius, so it's going to be no, not void, it's going to be const double get radius const return radius, right? And here it's just going to be void set radius, and then it's just going to be another one, so const double new radius, and it's just going to be radius is equal to new radius, right? So we're not going to check for negative values, right? So this is void. We're not going to check for negative values because we're just going to assume that the radius is only going to be changed with the mouse wheel. And let's see. Let's see. Actually, maybe maybe I should check for. Actually, let's try without checking just to see what happens. And here I can close this for now. And so I got these two methods here. And so here I'm just going to do something like that. Any errors or no? Mouse wheel event data. Right, so I had to put this. I had to put the wheel here. I had to call this attribute and then .y. Okay. Now if I run this, what does it do? Does it run? Okay, it runs. And if I do the mouse wheel, right, so this works. Is this a bit too slow? I feel like it might be a little bit too slow. So let's do like 3 times mouse wheel. Okay. And I guess the motion is fine. Like if I'm dragging it towards me, it gets smaller. But if I drag it like towards my screen, it gets bigger. It's like as if I was zooming. So I guess it's fine. It seems pretty logical to do it this way. But okay, if we look at it here, we can see that the angle distribution seems fine, like when the area is big, when the radius is big. But once we get a bit smaller, let's look at the behavior of the angle distribution. Right, so there are some rays that are really moving a lot. And yeah, just like a lot of information gets lost when the radius gets really small. And so the angle distribution just looks messed up. And if I get even smaller, if I get negative, what happens? Ooh. So if I get negative, it basically cancels out. Right, but I don't want this to happen. But if I go to basically 0, this is what I get. It's pretty funny. I don't know if I really care about this edge case, honestly. You know, what I can do is just here in light sources.h, I'm just going to do you know what, I'm not going to do it in line. I'm just going to like copy this basically and just do here. Okay, and now in light sources CPP I'm just going to do it. So I'm just going to do it as one of the first here, right? And so light source, right? So I got a new keyboard, so I'm still getting used to it. That's why I'm making a lot of typos. I mean, I was already making a lot of typos before, but I'm making even more typos now. Okay, let's do it this way. Okay, cool. Okay, and so this is just going to happen if new radius is strictly positive, then we're going to do this, right? Otherwise, we're not going to do anything. Right, let's try it out this way. So let's make it smaller, and I guess since this is really ugly, I should make it like a minimum. I should have a minimum, so like as long as the radius is above, I don't know, let's try 10. 10 seems like a lot. Right, 10 is a lot to be fair, so let's do, what happens if I do 1? What does it look like? Let's see. Looks fine. Radius of 1. What if I do 0.5? Because 0.5 should have a diameter of 1. Yeah, right, so this is not cool. So let's do 1 here. This wasn't looking good otherwise. And I think I know why it's not looking good if the diameter is 1, if the radius is 0.5. Because it's 0.5, but then we're going to draw pixels using 0.5, so everything is going to get rounded to 0, and then it's just going to be ugly. Right, so So I guess it's fine. Maybe I should do something exponential, like for the radius change. Maybe it should be exponential so that once the thing gets really big, well, it doesn't take so much time like to scroll and change it. But I mean, honestly, I think it's fine just the way it is right now. Okay, cool. So, first thing done here. So, here, done. Boom. Collisions with other shapes. Alright, so this is going to be um, the annoying part, right? So how should I do this? Right, so I should probably, so why am I on the Git page here? Git changes. So I should probably create a source file called obstacles. I think that's just what I'm going to do for now. Obstacles.cpp, and here in the header files, I'm just going to create a new header file called obstacles.h. Obstacles.h. Right. Now let's see, how should I go about this? Basically, I don't want to do any circular inclusion or whatever. So, so if I define my obstacles class here, I don't want to include ray or light sources in it, because in light sources or ray, I'm going to include obstacles. I don't want to do circular inclusion. And I feel like in my obstacles class, I do not need rays or light source, because the collision checking is just going to happen. It's just going to happen around here, like in draw. If I look at draw, no, it's calculate collision point. Right, so this is where the collision checking happens. And so here, obstacles, it's going to be, this is going to be just an obstacles class, right, instead of SDL rect. Okay, so, right, and I'm just going to include here obstacles H here at the end. So in obstacles, let's think this through. I'm obviously going to have an obstacles class and a private attribute, at least one, and some public attributes, probably a constructor, right? Now let's bring up paint. Let's see. So we have obstacles here. I'm going to call them obstacles. And so what are these obstacles going to have as attributes? So an obstacle, let's see. Does it have to have an attribute? Maybe a color. Maybe an obstacle can be defined. Every obstacle is going to have a color. Maybe not. I don't know. Okay. But I want this class to be abstract, right? So let's see. Obstacle class, what can I do? So it's going to have a constructor. So it's just going to have a constructor. Right, I don't really know how to do this right now. So what I'm going to do is I'm going to take all of this, just move it around the center here, and then I'm going to start with here. So we're gonna have another class called rect. Right, actually let's just type So we're gonna have rect, let's make it 36. Can I make it 36 here? Right, okay, cool. And so rectangle class. And so this is going to be, rectangle is going to have a width, height that are going to be integers, right? We're gonna have, so a rectangle can just be defined by width, height, as well as x, y that are int. Okay. Now it's going to have a constructor which is going to take exactly that. So start with actually x, y. Okay. And what else does a rectangle need? Maybe a color. So maybe just so private attribute, so RGBA. uint, so it's going to be unsigned 8 bits integers, right? And so another constructor here, x, y, w, h, RGBA. Basically just two constructors in case we want to set the color and whatever. Okay. So this is how a rectangle is going to be defined. I think I can make this a little bit smaller. Right, just like that is fine. What else is a rectangle going to have? Something like set color RGBA, and I guess move to x and y. So if I have move x and y, I'm probably going to have something like get x, get y. Probably going to have this if at some point I just want to move the thing vertically, right? What else does a rectangle need to have? I think that's fine. I'm not gonna try to rotate a rectangle or something. Or actually, I should be able to render it, and so render it, and then this is just going to take the renderer, and I mean as a pointer, but I'm not going to specify it. Renderer as well as let's see. So what are the options for a rectangle? It can be filled, or it can be just a rectangle with no color inside. So how should I call it? Maybe it's something like rectangle RCT mode. How did I call it for the light source? What did I call it? Type, right? So I can call it rectangle type. And that's all I need, is it? Sounds good to me. Render. And if I look at if I look at my light source here, do I have anything else? So I have render rays, right? But rectangles are not going to emit rays. Set color, render, move, and that looks good to me. I think that's fine. Like I can work with that. So let's do this. I mean, let's not code it right now, but I'm just going to keep it this way. So I cannot change it, right? Because paint is great. Okay, now if I look at an obstacle, for example, let's make it an ellipse. Okay, so ellipse meaning regular oval shape. So it's not. So if I look at it here, oval meaning. Right. So let's see, oval equation. Okay. Ellipse. Right. So that's how it is. I'll try just to resonate through this, and so one here. Mm -mm -mm. Okay, I'll just try to look at this picture and then come up with like use a math to like draw an ellipse. Okay. Okay. Well, I forgot something in rectangle. If I want to check for a collision with a rectangle, basically, I want to have a method that like basically sends the shape, like the pixels of it. But a rectangle, I can just use a draw rectangle function from the SDL library. So, and that is literally what I'm going to do. So here I can just add something like plus get shape, not get shape. It's going to be a getter, right? Get um, get shape, get pixels. Yeah, I guess I can call it get pixels. It's just going to be here, right? And so in an ellipse, what we're going to have is so an ellipse. How do we characterize an ellipse? Alright, so they have x and y, but how can I really call this in terms of attributes? Because x and y is going to be the center. So an ellipse is see my major axis, width and height. So that's just how they call it, right? And the width is 2a and height is 2b. So I guess it's just going to be the same. So width, height, and it's going to be integers still because we're talking about pixels. Let's make this a little bit higher, a bit lower. I mean, x, y, int. Same thing, RGBA. Unsigned integers. Now, an ellipse is going to use so x, y. This is two constructors. Because why not? RGBA. Okay. Set color RGBA. Get X. Get Y. Okay. Move X, Y. Render. Render and I guess L type. I'll just call it this way. And then get pixels. Or should I do it get pixels? Am I just going to use the collision like has intersection, or yeah, what was I using here for my collisions? I'm using SDL has intersection with obstacles. But this only takes in rectangles. So basically, if I want to check collision with an ellipse, that means that I'll have to basically do a for loop within all the pixels of my shape and then check if there's an intersection with the ray. But I feel like I'm just wasting resources by doing that because I mean it's going to end up working, I think, but I'm going to waste resources because uh, imagine, right? So I'm just going to add this, but like imagine that we have our light source here and we have an ellipse here. Our light source comes here. Um, then there should be a way to know for sure that we don't need to calculate this part, right? Like we don't need to check for collision here. Um, so this might get a little bit messy. Like it's going to be a bit slow if I check for collision for every single pixel over here. And I'm just going to check for the pixels in the border here, right? Only these ones, not the ones inside, because that would be tremendously useless. So this looks a little bit complicated, but interesting for sure. And I just got an idea. What if, instead of doing the obstacles class right now, what if, like, just bothering, well, instead of bothering with doing all of this, I just started doing reflection right now. So I think I'm just going to go ahead and do this because honestly, why not? I feel like if I do the reflection now, it's going to be a little bit more interesting for me, more stimulating, and then I'll have an easier time doing the other obstacle class. So, right, so let's take another look at what we have right now. So we got this, and we can change the radius and all that. That's pretty cool. That is pretty cool. Um, but, um, so now I want to do reflection. Okay. So what I'm going to do is I'm just going to comment out some stuff here. Just to comment out some stuff here. Boom, boom. And right now, if I run it, I shouldn't have a light source, only my obstacles. Right, and so what I'm going to do now is I'm going to have a single array. So it should be ray R1. And so what are the parameters here? So origin P1, P1 angle. Right, so but I just wanna basically I just want to have this. This is all that I think is interesting. So origin P1. So origin, let's just do like 300. Oh, it's a point, right? So origin, I guess 300. Then the point P is just going to be so it's going to start drawing at let's see, like 400, 300. Okay. And so if here I do SD, no, R1 dot draw, and here I'm just going to pass in render obstacles and count. So I guess that's 3. So now if I run it, I'm gonna get a white line. Good. Good. And then I'm just going to copy this and do the same color here. Basically, and now if I run it, I'm just gonna have this. Cool. But now I want to be able to control my line using like my mouse. So I want to be able to change the origin attribute as well as the p1 attribute. So void set origin SDL point new origin. Just going to do this here real quick. So it's going to be Ray, and then basically if so new origin x is above 0, and actually let's not care about this. Let's just do origin equal new origin. Can I just do that? And so if I look at this here, do I need to update anything? The angle is going to get calculated here. And when I do draw, what happens again? So the angle is here. So basically, when I'm moving the origin, my question is the new angle going to get calculated or not? Let's see. So in the constructor, I do calculate the angle, right? No worries about that, no problem. But I need to update the angle whenever I do that. So I suppose that whenever I draw it, I should update the angle whenever I do it, whenever I draw it here. So I'm just going to take this and in here draw. Basically, I'm just going to do angle is equal to that. O is undefined. So origin and here is going to be P1 and P1. Right. Let's do it this way. And so here I'm just going to do void set P1 SDL point new P1. Easy as that. Let's make it const while we are doing this. Just going to copy this, save, make this const, Ray, and so here basically it's just going to be that P1 will be equal to new P1. Okay. Set origin, no. Okay. And now let's do it with a left click and right click. So I'm not going to check for the button here. I'm going to check it here actually. So if event.button.button is equal to the left click, I'm going to change P1. So it's going to be let's see, r1.set P1, and here set P1, and can I do this? Mouse X, mouse Y. I think this works. And here if event button is equal to true, which I suppose is going to be right click, I'm just going to do R1 set origin, and here same thing, mouse X, mouse Y. Okay. Now let's say if I run this, what happens? right? So this is what happens. Let's see. Right, so this is basically where the origin is, and so if I really want to like manipulate it, basically, alright, so I can just do that, and this is enough. Like basically, if I can go here, and then I can bring in. Oh, okay. I think when I did a right click, it didn't do anything. Um, so maybe here I'm moving P1 when I do this. And here I'm doing a right click, but it's not changing anything, but it should change something. So set origin, mouse X, mouse Y, event button. So let's check the SDL events, or maybe it's written here actually. XY, mouse wheel, no, this is mouse wheel. So I'm not looking at the right thing. Complete API index, SDL, mouse, button. And so, oh, maybe I can use this actually. But mouse button index. Mouse button index. I guess I have to look at the GitHub here. And mouse button event. Okay. Mouse button event. Right, so if I look at button, mouse button, mouse button event. Do I get any more information about it? Right, so left click. SDL button, mouse left click button ID, but instead of being left, it's going to be right. Let's look at this. Okay, I'm not sure. You know what? I'm just going to try something here. If I set this to 2, is it going to work or not? Right, so this doesn't work. Oh, I get it. It's for the middle click. So for the mouse wheel, when I click on the mouse wheel. So maybe it should be 1 and 3 actually. And so 3 is going to be right click. No. 0? Is it 0? Well, that's not exactly what I wanted. But 2 is for like the mouse wheel click. 3 is nothing. 3 doesn't do anything, apparently. Let's keep it here actually. And so like if I do 2, so it's going to set P1, right? So it does set P1. And the origin, when I do left click, I can indeed like change the origin. So that's pretty cool. When I do 3, what does it do? Nothing, but I can indeed change the origin. 4, I honestly don't know. Ooh. So it is 4 for the right. Oh, right, because it's in binary. My bad. Yeah, that was a bit naive from me. I should have thought about it, but if I look at this, do I have any information from it here, like event button dot button? If I click on this, view code, nope. Go to definition. Right, I can just do this actually instead of looking at the documentation. But it's an unsigned integer with 8 bits. And so since it's using 8 bits, right, I'm stupid. Since it's using 8 bits, it's basically just a bunch of either 0, 0, 0, 0, 0, 0, 0, 8 of them, right? And so 1, so 0, 0, 0. I'm literally doing a computer science class here. So this is going to be the left click, and then this is going to be like the mouse wheel click, and this is going to be the right click, if I'm not mistaken. I have 1 0 too much here. And so this is indeed 1, this is 2, this is 4, like from binary to decimal numbers. Right, so if anyone's watching this, you probably know what I'm talking about. So yeah, right, so this was unsigned int, that's why I was doing the wrong thing. Okay, makes sense to me. Right, so instead of looking at the documentation, I should just look at the source files, at the source code. Okay, so basically right click is going to be here, left click is going to be here. Now let's see, if I do this, indeed I can move my P1 over here, and I can move my origin over here. So the origin allows me to do a full-on rotation, which is going to be useful for when I want to look at reflection. And being able to move my P1 is also going to be useful, because basically I'm going to be able to see, like, what if I make it render from here, or whatever. So yeah, I mean, pretty useful stuff here. Maybe I should like draw a rectangle for like for the origin. Maybe I should draw the origin with a rectangle. Not now, you know what? Let's just try to start doing the reflection. Okay. So if we look at the ray class here, basically we're just gonna do a reflection once we have a collision, and the collision we're gonna have one if we once we calculate the collision point. And so the collision point is either going to be one of the edges of the window or a rectangle, right? It's either going to be an edge like here or here, but it can also be a rectangle. But either way, let's look at the math behind the reflection. Maybe I'll just stop the video here, and the next video I will just implement the math that I'm going to talk about. So I haven't looked it up. I'm just going to come up with it right now. Right, so let's go a little bit further to the side here. Let's think about this. Okay. So we have a window. So we have our window here. Right, with a bunch of obstacles, which I'm going to draw in red. I'm trying to like do the same as what I have here. And in here, this color, I'm going to draw our ray. So let's see. I'm beginning here. So what I want to know about a reflection is, first I will want to know, once I know the coordinates of the collision, I want to know in which direction my ray was going. If it was going this way, if it's going this way, or this way, or this way. Because basically, if I'm going this way, I know that then I will just need to check for two things. Am I colliding with something on top? In which case the reflection is going to look like this. Or am I colliding with something like with an edge, like the right edge here, for example. In which case I'm going to go like that. So I need to know the direction. So the direction is going to be like, the directions can be X direction and Y direction, right? And these And I can easily calculate this by just doing p1 minus origin, p1x minus origin x, and origin x minus p1 origin y minus p1y. I did the other way around because just let's remember that we are in this coordinate system where y is going down and x is behaving as usual. So so yeah, I need x direction and y direction. Okay, so let's write it here. Oh, let's make this much bigger. 36. Okay. Need x direction, y direction. Okay. And then I need, how do I know if I'm colliding with an edge that goes here or here? How do I know this? How can I know with what I'm colliding? Well, I can do two things first. Like I can have a method called is colliding with window, and basically if right, so this can be done rather easily, I think, if I look at Ray's CPP here. If at the end of this method collides is false, that means that I'm colliding. The point of collision is one of the edges of the window. And so if the coordinates of the collision point of collision, is the coordinates of the window, I can easily know if I'm located like on this edge, or this edge, or this edge, or this edge, right? Because this is basically just going to be x equals 0, this is going to be y equals 0, this is going to be x equal window width, and this is going to be y equal window height. And so now let's look at the, so I'm just going to do collision with the window first, and then I'll do the obstacles. And so let's look at the math behind it. So imagine that I'm colliding, so let's just erase this. Let's imagine that I'm colliding here with the window. So I have an initial angle here of alpha, and basically here I'm just going to draw a new ray. I'm just going to draw a new ray, and alpha, I'll find it again here. This is alpha. This is the same angle, right? But is this how I want to view it or not? I feel like this is not the right way to view it. Maybe I should view it as here, alpha. Wait, I need to be certain of something. Is this alpha or is this 2 pi minus alpha? Right, because this cannot be alpha and this as well. It has to be only one of them. So let's see. It's probably just physics, high school physics, but listen, my brain is too busy learning physics that not a lot of people use. So I tend to easily forget high school physics. Right, so we have our angle here, and now let's try to draw this. Right. So basically what I can be sure of is that there's going to be some sort of symmetry between this and this when it collides. It's going to be symmetrical, like these 2 points here and here are going to be symmetrical. And so this here is going to be alpha, and so this here cannot be alpha. Alpha has to be, let's see, this cannot be alpha, can it? Let's just do some geometry, right? Because we love drawing stuff. We like to draw. And so, right, and so here, this is alpha. So here, this has to be alpha. Okay, so we found alpha. That's pretty cool. But in reality, it's not alpha, it's minus alpha, right? Because here the arrow is going in this direction, is going down, and so if I'm based on this coordinate system, my initial angle is alpha here, this one, and I mean this one, and then the reflection is going to have an angle like this. Right, but it's not going to behave the same way for every type of collision, right? This depends on the direction and the surface that we are hitting. So this is going to be minus alpha. Now, so I guess we have a few cases to study, like particular cases. So it's going to depend on the x and y direction. So this is a case where x direction is positive, like is basically equal to 1. We go this in this direction, and in the y coordinate we go this direction, so and y direction is negative, and this results in an minus alpha reflection. Okay, now what if we're going with x direction and y direction both positive? And let's not forget, this is the case where we are hitting the top of the window, because it's going to behave differently if we are hitting the edge, like of this rectangle, for example, where basically here what's going to happen, so we have alpha here, and we're going to go here, and I think here we're going to find our alpha. And so alpha, the value of alpha is just not going to change. What is going to change is, oh wait, I just got an idea. We shouldn't change alpha. What we're supposed to do, what we should do instead, oh right, this makes everything so much easier. I was overthinking everything, I think. Instead of changing alpha, we just need to change the x direction and y direction. Right? But the x direction can just be defined as cosine of alpha, and y direction can just be defined as minus sine of alpha. Minus because, as always, we're in this system, and I want a positive y direction to mean this. Or am I being stubborn if I do this? No, because my angle is defined as going in this direction starting from here. So I should keep following this logic. So right direction is going to be defined as minus sine alpha, and basically it's not going to be defined exactly by the value of cosine alpha, but rather if cosine alpha is negative, then x direction is going to be equal to minus 1. So below 0 means minus 1, above 0 means 1, and this for minus sine alpha, same thing, minus 0 means minus 1, and above 0 means 1. Right. This is how I'm going to get that. And so basically each time I have a collision, for example, so I'm starting here, and I know I'm colliding with the top window, so all I'm going to do is I'm going to keep the x direction, but I'm going to change the y direction. And so basically I'm going to go from y direction equal to 1 to y direction equal to minus 1. But to reflect that, well, mathematically, if we're looking at the angle, it's like just doing, so it reflects here like what I was doing earlier. It's like just going from alpha to minus alpha, because if we look at cosine of minus alpha, that's equal to cosine of alpha for every alpha possible. And sine of minus alpha is equal to minus sine of alpha. And so that's why. And so how do I go right? So it can just be easier to like visualize everything with a x direction and y direction attribute, or like just a variable that I'm going to create in my method in the functions that I'm going to use to calculate like the angle of reflection. But in reality, it's just about alpha, like the value of alpha. And so basically, I'm just going to do a lot of things, like if I'm going to do 2 to the power of let's see, I don't know how many cases I'm gonna do. 4 cases maybe. Yeah, right, because it's going to be 2 to the power of 2, so 2 times 2, so 4. And I'm just going to do like if x direction like this and y direction, then I'm going to do some stuff, else if, etc. And at the beginning, I'm just going to define x direction as like I'm going to look at cosine of alpha, and if it's positive, I'm going to set x direction to 1 and all that. And then I'm going to do a lot of if else's. Yeah, I mean, I think that's one way to go about it. Another way to go about it would be to like just define a maybe like an attribute, like a boolean, not an attribute, but like a boolean variable called I don't know, like something, and it will be equal to x direction above 0, and I mean basically it will be equal to our expressions that we are testing. And then based on the value of that, we can do some stuff just to make the code a little bit shorter or readable, I don't know. But yeah, I mean, I think basically the function is just going to be a whole lot of if and else if. And so yeah, I'm gonna stop here for now. In the next video, I will implement this. And in the next video, hopefully, we'll have the reflection working. And then in the next video, or in the same video, I don't know, depends on how much time I'm gonna spend doing the math, like just doing this. Then we'll add like the amount of reflections that we want. Basically here, if I draw a ray, it reflects here. How many times should it reflect? Should be something that we can choose easily, that the user can just use with the keyboard, like by typing on 1 or 2 or 3 or 4. It's going to decide on the amount like that. And yeah, okay, let's do that in the next video. So thank you for watching, and see you in the next video.